All right. Thank you, everybody. This is the July 2025 installment of the Microsoft Data Platform Continuity Virtual Group. Thank you all if you're in the US. We really appreciate you coming out after a holiday weekend. Otherwise, I hope everybody's staying safe and cool and or warm, depending on where you're at in the world. With me today is Tim Radney. We're going to be talking about SQL Server common mistakes and how to avoid them. So with that, turn that over to Tim.
All right. Thank you all for tuning in or watching this afterwards on YouTube or wherever. So common SQL Server mistakes and how to avoid them. So this kind of started off as a blog post. David, it was like my first one. Is you inherited a database. Now what? So that early days in my career, or soon after, when I got started and started learning all these things, I'm like, God, I wish there was a session or something out there that covered all these basic things that somebody should have set me down and said, hey, so when you run setup, next, finish, here's all the other things that you should take into consideration for that instance to make sure that it runs as smoothly as it could and that you're protected and all the things that you would expect. So 15 plus years of speaking, and this session is still has life to it. It's been worked on quite a bit, new things added, modifications. So you'll see a lot of that, out here. So we'll jump in. So my contact information, feel free to reach out anytime, tim@timrandy.com. You can find me online on the socials and things. Happy to answer any questions, happy to um, share any links, blog posts, things like that with you. So like I mentioned, this has evolved over time. So another version of this is best practices for the hybrid DBA. It's like, what of these things that you would do for the box version, the SQL Server that you would install on your virtual machine or on an Azure, AWS, Google, OCI, wherever, the box version, you're running setup, you're not running the platform as a service. I'm going to talk a lot about those, but what does that mean if you're running in platform as a service, managed instance, RDS, any of those other types of platform as a service? There's still things that you need to do. And so we're going to kind of highlight those. So I have a little legend, whether it's SQL database managed instance, infrastructure as a service, that covers you're running SQL Server somewhere else, but it's the box version, or SQL on-prem. And to me, SQL on-prem, SQL IaaS, pretty much the same thing. It's it's on a server somewhere, whether it's physical or virtual. So we're going to cover your backups, consistency checks. I'm not going to read all the bullet points. You can see those for yourself. You can pause, read. I'm going to move along so we can start getting into the meat of the session. So first is backups. We were just talking about this a little bit before we kicked off the session. Is how often we're finding still today customers and people out there that do not have proper backups. So are you taking regular backups and can you meet your service level agreements? So those SLAs. What are some of those SLAs? What are we kind of measured against? Recovery point objective. Like, how much data can you lose? Recovery time objective. How long can you be down? Those are always fun to get into the conversations with customers because you get no downtime, no data loss. Not really realistic if a meteor hit the building, but you define what that is. 15 minutes of data loss, 30 minutes of data loss, 4 hours for a complete disaster, things like that. And then that's going to determine your kind of your recovery strategy. What do you have to have in place in order to be able to restore to that level? And then that's going to tell you the types of backups and intervals and things like that that you're going to go take. Also, what recovery model? So if you need point in time recovery, it's going to be the full recovery model. Are you validating those backups? David, I know you've got similar war stories that I have on customers. Oh yeah, we're backing up. They're good.
Webinara, żeby się tam.
It's like, have you ever restored them? Have you tested that? Finding backup jobs that are backing up to disk null. Finding where someone excluded a database because it was just filling up the backup drive. So, oh well, let's not worry about that biggest database, and the backup problem, the space problem goes away. So by regularly restoring, you're able to kind of validate those things. More importantly, You're making sure that you can recover, that they're good, but you're also figuring out how long those are going to take. If you have a 4-hour recovery time objective, that starts at the time of the outage. If somebody has to restore a virtual machine, restore Active Directory, restore the network, all of those things, and it takes a couple of hours, now you get access to the system. You've got 2 hours to restore a quarter petabyte of data. It's not going to happen. Third-party backup vendors and things can help you with that as well, with having methods and timing and estimates. But the best way is by you restoring, what it takes, and then depending on time and all of that may help you realize that you need a high availability solution or a better disaster recovery type solution with log shipping, distributed availability groups, different types of things in order to meet some of those SLAs. So I've got a script out there. I still use it. I was using this last week that tells you the database name, the recovery model, when was the last full, the last differential, the last 2 transaction logs. I think I mentioned the recovery model. So that way I can tell, is there a database in full recovery that's had no transaction log backups? So now I know the transaction log is continuing to grow. Or I can ask, hey, so this database is in simple. What happens if you can only restore it to last night's full? What impact does that have on your business to lose 12, 18, or 24 hours worth of data? So, oh, not a problem, then move on. Usually it's the other way around. It's, oh my gosh, we would be ruined. Well, let's change to full, take a full backup. So it's just kind of stepping through all of that. Now, some good news is if you're on platform as a service, backups are kind of built in. So Azure SQL Database, Managed Instance, they're taking care of that. It's a managed backup. When you go to do a restore, you say which database to what point in time, and it goes and kicks that off. But if you're anywhere else where you're responsible for the instance, you are responsible for your backups. And I still say test those everywhere you're at, just so that you know what is the process to go restore that in a managed instance or a SQL database or RDS, or any of those other kind of managed providers. All right, consistency checks. This one's kind of near and dear because I worked for Paul Randall for many, many years, who wrote DBCC CheckDB. And being with that company for many years, got a lot of emails where people would come across corruption. How do we recover? How do we repair? Many times you get lucky. It's like roulette. You're gambling. You vote red, lands on red. Hey, we're good. It was a non-clustered index that was corrupt. You simply drop and recreate the index. Awesome. It's the clustered index. Can't really drop the data and recreate it. So in certain situations, the way that you recover, you eliminate that corruption, you recover from it, is restoring the database. Well, 99.98% of corruption happens at some IO subsystem layer where SQL Server was told, hey, the data is committed to disk. And then later when it goes and tries to read those ones and zeros, they're no longer there. What it expects to find on the disk is not there. An analogy I like to say is I've got 2 daughters, and like my wallet, I leave it on the counter. I know there's 5 $20 bills, in there. That's, I know it. I go back, I open my wallet, and 3 of them are missing. That's logical corruption. There should be 5, 20s, 2 zeros, but there's only 2. So there's a consistency issue from when I left it and when I came back to it. Therefore, my wallet is corrupt, or a child is corrupt for stealing my money. But so with that, depending on what the error is and where it is, non-clustered index is easily to repair. Clustered index or the heap, you're typically restoring that from backup. Well, since it was done at the disk IO subsystem, it's not really transactionally, it wasn't corrupted via transaction. So as long as you have your full differentials, transaction logs up to right now, you can restore and get back with 0 data loss, or at least up to when, depending on the level of corruption, when that happened. So you can drastically minimize data loss by having the proper backups. But how are you going to encounter and know corruption is there? Well, either it's severe enough that SQL Server detects it, immediately and you start getting these fatal errors, that's really bad. But if it's a logical or not as severe, it's only when you go to access that, you're only going to know when you run dbcc check db or a customer tries to access that data. So there's databases that are out there that have been corrupt for years and nobody has found them because they never run checkdb. And then you go to run checkdb, you find it. Well, how far back was it? And it becomes a very interesting situation. So with that, I like to run checkdb at least once a week. And then you want to take immediate action if it fails, because depending on your backup retention and all of those things, you need to be able to recover from prior to the corruption happening. And, I could spend a lot of time charts, graphs, and kind of go through and talk about retention periods. But basically, if you're checking on Sunday and the error happens on Monday, you go a full week before you run checkdb again, and then it fails. And maybe you're on holiday that week, and then you come back and checkdb failed a week ago. You run it again, it fails again. Or you're now about 2 weeks from when it happened. What's your backup retention? 2 weeks, right? So you can kind of see where that can get a bit weird or dangerous, based on the frequency of you checking, backup retention. So just have all that in mind when you start planning out potential disasters. And this is really true for all systems. Now, there is a blog post out there where Microsoft says, hey, we're doing CheckDB scans for you in Azure SQL Database, but unless something has changed, they don't say which copy because it's all locally redundant. So there's like 3 copies out there. Are they scanning a subset? Are they scanning the primary that you're on? All of those things. So hey, thanks for you doing your work and doing all these scans. That's awesome. Appreciate it. But I'm also going to verify. I'm still going to run it. I have the maintenance window. I have the time that I can run it for my own peace of mind because ultimately I'm the one that's responsible. Because if we get corrupt and we lose data and my job's eliminated because of that, I don't care that you're to blame. You were supposed to be checking it. It's on me. I would rather, hey, I get an error, I report it, Microsoft does some magic, and then we're still in business. So for my peace of mind, I still run it in all environments. All right, that's kind of the gloom and doom. Now let's talk about some more lighthearted stuff. Logs. So nobody told me when I became a DBA that our homegrown backup solution, we weren't using Ola Hallegren. Back in the early days, every DBA thought they could do it better, and they had their own custom processes. And MSDB keeps up with that, and unless you're purging that, it's going to continue to grow and grow. And so I inherited an environment that had about 120 databases, log shipped to another server, log backups every 5 minutes, and the server had been up and running for around 7 years. MSDB was about 30 gigabytes in size on SQL 2000. You could not right click and say restore and it not crash query analyzer back in those days. I mean, it was just dead. So that's when I learned about SP_delete_backup history. And back in those versions, Jeff Heighton had some blog posts out there with some indexes that you could go and create that would drastically help improve. And eventually those got worked into the product. But it's still, Ola Hallegren, if you run his index or his database maintenance solution, there's a job that is delete backup history. It's there. You just have to schedule it. And I find systems all the time. Oh, yeah, we're using Ola. Great. Let's go take a look. Oh, you didn't schedule all those jobs. You got the consistency check, the index optimize, the backups, but you're not running the purge, the purge processes. So let's schedule those real quick. So that's one of the big ones. And as a consultant, I still encountered that over and over and over again. And then there's a lot of others, Service Broker and Database Mill. MSDB stores some stuff. So taking a look at MSDB, if it's over, say, a gigabyte, look at the tables to see which ones are large and see if you have some bloat somewhere. But backup history is typically one of those. And this is only deleting the metadata, the backup, when the backup happened, all the statistics about it. It's not the actual backup files. SQL Server log maintenance. This one's fun. By default, the log rolls over every time SQL Server service restarts, and it keeps 6 logs. I think most of us on this session have encountered where, hey, there's a problem with SQL, and you go to look at it, and it's set to these this default, and somebody before you just tried rebooting the server over and over and over again, and you look at it, and it's been restarted 6 times, and the oldest log is like 2 hours ago. So you have no error log to see what led, what events led up to that. So you couldn't see it healthy before it turned bad to see any of that history, or vice versa. You jump on a machine and you want to look at the recent log. I just want to see what's been going on the past day. And your current log shows like last year. The server's been up and running forever, and it's like 7 billion records. So it's like, let me fire up Notepad++ or something to go and look at that, try to open that file because it's going to crash Management Studio. Or, hey, I'm paid by the hour, so I don't care. I'll sit there and let it load for 45 minutes. But cycling these logs. So just a SQL agent job, running execute sp_cycle_error log, midnight every night, great time. Now fresh log every day, and then right click on the log, go check, uncheck the box and say you want to keep 30, 40, 30, 35, 40, some number, more than 6, so that you can have more history. And usually what I do is around 30. That way, if there's not been some frequent restarts, I've got roughly a month worth to go back. But the reality is I'm usually only looking back a few days to see, when something happened. Why it's good to have like a month ago. If somebody calls you up and, hey, we're having this problem and I noticed this error. Okay, when did your problem start occurring? Well, 2 days ago. Okay, well, that error that you think is the problem has been there for a month. That's not, that is a problem. We'll go take a look at it, but it's probably not related to this particular issue. So it's as much to prove something's not the problem versus being able to go back far enough to see maybe when something started happening. But these are just kind of freebies to go check, put in place. Neither require any type of service disruption to implement. So if you come across a system that doesn't have the log maintenance, you can create the job. You can run the stored procedure to cycle it right then if you need to. That's fairly common. If I see a file that's really, really old and big and they're having problems right now, I'll go ahead and cycle it so I can see fresh things coming in to see the errors. But yeah, this is mostly your infrastructure as a service on-prem situation. All right, so deleting that backup history, simple. sp_delete_ backup history, and then pass the date that you want to delete everything older than. So it's very common here is declare at date, date time, set at date equals get date minus 30, and then execute the stored procedure, pass it at date. SQL agent job, let it run, it does its thing. Most of your third party, if you're using Rubrik, you're using SQL Backup Pro, you're using any of these third party backup tools, most of them handle that for you and have a default built in. It's probably 30 days. All right, statistics. This one is very near and dear. Updating statistics. So SQL's gotten better at this. It used to be that auto update stats would kick in after 20% of the data plus 500 rows changed. We had a trace flag we could go and throw in there that would decrease that value. Now that trace flag is enabled kind of by default. And I absolutely love that the formula includes a square root. Never in my life in any other situation have seen square root used in the real world. Now, given I haven't worked with NASA or SpaceX or any of those crazy advanced companies, but there is the formula, which I really should get that formula and put it in the slide. It's a square root. So based on the size of the table in this equation, will determine how many row modifications before auto update stats kick in. So that's awesome that it lowers that value. because very big tables, 20% plus 500 rows is a big number. It's like, just think about it. You have more than 5 years of data in a table. Your finance, you got 7 years, so you got more than 5. So you're telling me at least a year's worth of data has to change before statistics is updated? That's not good. Well, why is that even, why do we even care? Well, the query optimizer uses statistics to generate or formulate the execution plan. So if it's working with old data, it hasn't seen that our customer purchasing has changed because of whatever reason. Our Kardashian talked about our product line, and now sales are crazy. We want to know that so that the optimizer can formulate a more efficient plan for the workload. So we do that by running update stats. And there's a couple of ways. I mean, you can run sp underscore update stats. You can pass it different parameters. If you're using like Ola Halloran in the index optimized procedure, you can pass it parameters to say at update statistics equals all or some value. At only modified statistics, so only when there's been row modifications. You can tell it what percentage of row modifications, and then that may conflict a little bit with the auto update based on that formula. But the point is you're not relying on auto update stats to maintain your statistics. So this, most customers, I'm doing this nightly. It's like, why not? Something to take into consideration is your index, which I think is the next slide. If you're doing index maintenance from fragmentation, so an index rebuild updates statistics, an index reorganize does not, which is also why it's important to have maybe a separate index or statistics updates job to make sure that you're keeping those up to date. Now, index maintenance fragmentation, there's some questions out there of, is it still important? Yes and no. For me, most, yes, I'm still taking care of fragmentation, and I'll tell you why. A lot of it's based on real world, what I've seen out there. But an old white paper, Microsoft did a whole bunch of case study, found that up to 460% improvement of query performance with eliminating fragmentation, but that also updated statistics, right? Well, that was on spinning disk. Now we have solid state. Much, much faster. But what is fragmentation? It's empty space in your pages. Anybody have more RAM on their server than database size? So let's say you're running a terabyte of RAM with only a half a terabyte data. If the whole thing can fit in memory, you're solid. You're good. But I'm still working with customers that have like 4 and 8 cores, 30 to 64 gig of RAM. They're bound to some of these shape sizes that they just can't afford to do. What's the Azure term is the
Constrained core.
Constrained. Where I'm going to pay for the compute to get the more RAM or the memory optimized. It may not be tremendous amount of wasted space, but there's still some wasted space. And then I've just seen some weirdness where statistics are up to date, everything's good, but performance is still a problem. And I go look, and there's highly fragmented tables. I'm on ultra fast SSDs, but I still go and take care of the fragmentation, and performance is better. It's a weird thing. So I was following some different blog posts where it was like, oh yeah, you really don't have to worry about this in Azure and other things. And it was just comment after comment after comment of people saying, yeah, I hear you. And what you're saying sounds logical. However, in the real world, we stopped, we started having problems, we put it back, and problems went away. So mileage will vary. I still take a look at this. I don't get as aggressive, but I'm still taking a look at fragmentation, defragging where appropriate. Curious that David, in your experience, what are you seeing now? Because I mean, pretty much everybody has solid state.
I tend to agree with you on this one. I don't see any reason not to. If you've got the maintenance window, you may not get a tremendous boost, but there's something. It may be measurable. You may be able to feel it. In some cases, it's big. If you've got a lot of data churn all over the place, that plus stats, I think it's worth doing.
But and I've heard the arguments that this leads to page splits and all of this other stuff, and I agree. I mean, the science is there. It's yeah, what you're saying, I can follow, but help me understand why when I run this, things are better. What is this doing that is a side effect? Right? Is it what symptom of the bad is making this other thing good? Right?
Yeah.
And this was the trusted, the go-to, do this for all systems. I just can't believe that all of a sudden now it's the wrong thing to be doing when this was our livelihood for decades, um, solid state or not. And people, please, if you're on, you're hosting somewhere else and they tell you it's solid state, yes, it probably is solid state on that storage array. But now you've got all these layers of fabric, not the Microsoft fabric, networking and HBAs and virtualization and all of that, to where, yes, it may be super, super fast there, but you're being throttled somewhere else on throughput, on IO, on something else. If it's all physical machine, like my desktop, 32 cores, 128 gig of RAM, 4 terabytes of NVMe. David, don't laugh. I know that's like nothing for your lab. But
That's a heck of a setup.
right,
That's awesome.
it's difficult for me to show any kind of contention, right? But on my virtual machines, I can go and throttle things and make it worse. So just because it says SSD doesn't mean it's equivalent to a local SSD in your machine, unless you're paying for bare metal or some special ultra SSD something in one of the cloud providers. All right, so how do we control it? Index reorgs, rebuilds, database maintenance plans. You can now specify based on fragmentation levels. Third-party tools do it. Again, I fall back. I've been using Ola for, gosh, what feels like 20 years now. It just works. I mean, there's quite a few different methods out there. The important thing is do something and what's right for your organization, and don't just do everything whether it needs it or not. I mean, use some logic. If it's a archive table, there's been no insert, update, delete, no reason to rebuild with force every single night. All right, memory settings. Ooh, this is another hot topic. So do you let SQL Server manage it? Do you still set values? What are you doing? I rarely come across 2012 and older, although I did come across a 2012 last week. 2016, or was it? No, 2012 was the memory manager rewrite, where we were told we didn't have to be as concerned with leaving the defaults of 2 petabytes, but yet we still were all recommended to set a max value. Back in the day, we were setting it to prevent the the storage pool from consuming all memory. Now there's some built-in safeguards, but I really would love to get on a committee and talk with other consultants on, what are you seeing out there? Because now I've been starting to back max mem down to 85% of the available memory. Whereas before it used to be, as long as you would leave a few gigabytes to the OS, you were good. And so we could run SQL Server at 95, 96%, and that was the norm for total OS usage. But seeing so many systems like CrowdStrike and Qualys and FireEye and all of these other systems, doing the threat detection and all of that, is we're having to give the OS more and more memory because we're starting to see, memory pressure to SQL, to where that 85% is more of a sweet spot. And Pedro Lopes, before he left Microsoft, was even saying, yeah, on Windows systems, you really need to start backing this down. And we're all like, no, that's absurd. That's expensive to give up 5 or 10 gig of RAM on SQL. And then lo and behold, I mean, it has come to fruition where for most people I've worked with and customers, we're having to back it down. I mean, we're 92% used to be kind of a norm. It's getting that down to 85%. Some customers even less if they're using, SSRS and other modules. Have you seen anything similar, David?
Oh yeah, I have seen far too many occurrences of that. Um, Even some of the things in SQL Server that run outside of the buffer pool are eating more RAM.
Mhm.
The EIP services are using some, all this extra third-party stuff, especially all the security tools you mentioned,
Yeah.
including, or and those and a lot more. I generally start at 75%, depending on how much RAM you have, and you need more for the OS with the more that you allocate, and then sample the available memory in Windows and then adjust going forward. Um, yeah, you don't want to starve Windows, so kind of start small and kind of inch your way up after you get real world telemetry.
Yeah, but it used to be what was the measure for starving? I mean, you remember back in the day, oh, 300 meg available. It's like,
Yeah,
that's splitting hairs. Maybe a gig or a couple of gig. And now it's like I'm finding systems where I need to leave, 10, 20 gigabytes, because
or more.
these other systems, when they fire up, it's quick, but it may ramp up and use 6 or 8 gig and then go away. Well, if it did that for 5 minutes, you just crush SQL. It's having a page out, and then now it's back available. What's SQL going to do?
Yeah, try a
Slurp it
machine
back up.
with 6 terabytes of RAM. I'm leaving a couple hundred gigs of RAM open.
Yeah. So there you all go. How much is enough? Well, mileage will vary, but starting at some number and setting that max. Um, I remember right after 12 came out, and it would take, Bob Ward was, I think it might have been in Austin, Houston, was talking and had mentioned, the numbers were like 90%. Said it would take 90% at startup. That was kind of the upper ceiling. And then over time, if SQL Server came under pressure, it would look to see what is available to the OS and then would take up to 50% of that. Well, let's just do a hypothetical. If there was 100 gig, SQL would take 90 of it, leave 10 to the OS. All right, OS is using 4. SQL needs space. It looks, it sees that there's 6 gig available. It would take 50%, so it would take another 3. So it's using 93%. Well, David said 75. I'm saying 85. So that would be potentially too high for SQL to be, consuming. But with that back in the day, when we didn't have all these other things competing for RAM, was that 90% and up to 50% could have been too low. Where we go and look at the M bytes available, and there's gigabytes upon gigabytes available to the OS that it is never going to use. You look at the max, the min, the average, and the max is still leaving 30 gig available. Well, what do you do then? You have to go and set max memory for SQL to a higher value than the internal memory manager allocation was allocating to it, so it could use the available memory. Well, fast forward 10 years, 10, 13 years. Now we're back to having to set a value to restrain SQL from using so much to have enough available. And it's just that everything has gotten so bloated. I mean, look at desktops and laptops. You used to be able to get around or get away with 4 to 8 gig on a laptop to just do homework and check email and do things for that a student would need. And now you got Chrome, you got Edge, you got all these systems that just a browser's using 4 to 6 gig with a few tabs open. It's like everything's just bloated and consuming more to where we're having to back off the max memory value, or if you can, just add more RAM to the system. So instead of it being 4-core 64 gig of RAM, it's 4-core 96 or 128. So those are changing, but I'm not seeing some of those shape sizes accommodating. So you're having to spend a lot more money to get constrained cores or things like that. All right, moving along. Max degree of parallelism. So with this one, I mean, there's newer guidance. Your default of 0 would be, up to 64 cores that the SQL Server could use for parallel plans. SQL 2008 through 24, it was pretty straightforward. You got 8 or less, then you set the value to the number of cores. 8 or more, start with 8, and then adjust. SQL Server 2016 introduced soft NUMA. This all gets weird with the virtualization and different values. But pretty much the standard guidance is if you have more than 8 physical cores per NUMA node or socket, soft NUMA nodes are created automatically. So the engine handles a lot of that. NUMA nodes with less than 16 logical cores keep maxed up at or below the number of logical cores. More than 16 set maxed up to 16. Multiple NUMA nodes with more than 16 then set to half the number of logical processors. I'm fortunate a lot of the machines that I'm working with aren't hitting some of these thresholds to where I have to go and really worry about it. But then they're also all VMs running in some cloud provider. So curious, David, because I know you work with a lot in the VMware Hyper-V virtualization space. Are you still setting maxed up, leaving it to 0? What do you do?
I set it. The rules of thumb that you mentioned are generally what I adhere to. It goes back to the type of workload that it is. And
Yep.
when you're just walking into a machine you've never seen before, you may not really know. But if it's OLTP, the stuff works great. If it's more decision support, maybe the workload will take advantage of more than that for parallelization. Most of the time it won't, to be frank, or you get diminishing returns on it. This is exactly what I follow. And
I'd
it's
say it's about
20.
80%.
Yeah,
80%, it's right, setting the best practice, it's good. And then you have those weird workloads where they just death by a billion cuts. It's like, you know
yeah,
what? 8's too much.
dial
Drop it to
back.
4, right?
Yeah, and I know it's 2025. I still see this as being a problem. There are a lot of virtualization platforms out there that get this wrong,
Mhm.
or system admins that they're not paying attention. It's easy to mess it up. It doesn't tell you. So just
Right.
keep your eye on this, everybody.
Yep. And it can change over time. I mean, customers adding more workload, growing their business, changing how they're doing things. So very few things on a SQL Server are set and forget. And it's a constant tweak, which, hey, thank you, means we always have something to do.
Yeah, or even little things I saw this a couple months ago. Somebody had a machine with 8 cores, no big deal. It was running a little bit slow. They added 2 more cores. Automatic soft NUMA kicked in. Now you can only parallelize to 5 cores, so everything slowed down. They removed 2 cores, everything sped up. They wanted to know why. That's why.
Well, it's just like I've got a 32 core virtual machine. It's slow.
Yep. Throw
Um,
more cores at it.
it's like, well, if we drop that in half, it's going to be better. How? Where you're reducing that
Science.
CPU ready time.
Yep.
So what I have found that is so remarkably important is this cost threshold for parallelism. What determines when it goes parallel? How expensive does it need to be? The default is 5, and I think it's was it Ozar that coined the query bucks or no ah, who oh well, I'll think of the name in a moment. Anyway, so it's the 5 back in the day, and I think it was like SQL 2000, could have been 6.5. It was an HP workstation. I do remember that. Is that the value of 5 was that on that particular machine, it would take 5 seconds to execute. So if it was going to take more than 5 seconds, then parallelize, you break it up. Well, that was the algorithm that was built based on the number of cores, the speed of the disk, all the factors that played into that. Well, that didn't kind of scale when you started getting multi-core, faster disk, more RAM, all of those. It was still based on that value of 5. So it was a unit of measurement, but it didn't mean 5 seconds. So 5's way, way low. I mean, that's almost insignificant. That if there's what do they call trivial? It's almost like a trivial plan at a cost that low. So we only want more expensive things to go parallel. I think we've all used the phrase before. It would take me longer to show you how to do it than for me to just do it myself. So that's what we're trying to prevent here. Prevent trying to divide this work up across multiple threads and they all go and do a piece of it and put it back together. You want to reserve that for the really complicated queries. So if it's just quicker for me to do it myself, it needs to be below that cost threshold for parallelism. Well, what is that value for you? It depends. It depends on your workload. I usually start 25 to 50. One of my big clients, it's 50. A client I worked at, I probably could name drop them, but anyway, their number was 250. It's like, it's got to be expensive. But they knew their workload. Well, Jonathan Cahias wrote a blog post. So you can go to this link. These slides are available on my website. I'll have that up in a minute. But you can just Google Jonathan Cahias or performance tuning on or cost threshold parallelism performance tuning or something like that. It'll lead you to Cahias's post on SQL Skills, where it's just a query that you can run, and it shows you all the current plans in the buffer pool and their cost threshold for parallelism. And so you can go through that and look to see where are they grouped. What is that kind of hotspot? And maybe it's 55, 75, 25, but you'll see this big grouping. And then all of a sudden there's a big gap and the next one is like 1,000, right? Well, that's pretty expensive. So you probably want that one to be parallel. But if your kind of sweet spot is at 75, 80, somewhere in there, start looking at those plans. One, can you tune it? Can you make it more efficient? Go do that. If you can't, execute it with maxed op 1 versus parallel. If it's more efficient, maxed op 1, well, you could probably increase this to a number a little above that to then fine tune your workload for the cost threshold for parallelism. And it's always fun to find a machine that has 5 and you see all this expensive stuff. And then go adjust this up and see that stuff go away. All right, this is becoming less and less a silent killer with TempDB because there's been so much work done to SQL. But it's interesting when I asked some of the program managers over the storage engine that this is their product, even for 2025, which is going to have some additional benefits with TempDB, is do we still need multiple files to handle GAM, SGAM, PFS contention? Because they've done so much work to help eliminate that. And it's like, well, technically, you probably don't. I'm like, but what would you do? Yeah, I'd still put them in there. It's like, you may not need it, but it's not going to hurt. So interesting characteristic, great interview question is, how often should you back up TempDB? Well, you don't, right? It's recreated at startup. There's only one TempDB for the entire instance. It's modeled after the model database. Technically, yes, you can back it up by like backing up the storage, but when you restore it, you're not restoring TempDB. But if you try to do backup database TempDB to disk, it will throw an error. Just so you know, not that you care, right? So what are considerations? You need more than one file. Reason being is, PFS, GAM, SGAM. PFS repeats every 64 megabytes in the file. GAM and SGAM is every 4 gigabytes. And traditionally, we could see contention on PFS, GAM, and SGAM if you have one file and it's small. So if it's less than 4 gig, you got one PFS or one GAM and SGAM file and several PFS. But again, that one repeats every 64 megabytes. So it's just math to have more. Well, you create more files. And so now there's more files able to respond to that workload. There's been improvements, like I said, with the various newer versions. SQL 2016 did some stuff. 2022, 2025 has more improvements. We used to say turn on trace flag 1118. So when you create an extent, all 8 pages are created at the same time. That behavior is on by default in 2016 and above. Even instant file initialization is enabled if you check the box. So a lot of these things that we used to have to manually go and do and configure are now options with installing, or the behavior is on by default. But I still come across some workloads where TempDB is just destroyed because of, I don't want to say bad developers, right? But because they could do some nasty things, they're doing some nasty things, and TempDB is just the bottleneck. And so those multiple files come in handy because now I can go and put parts of TempDB on different physical disk or virtual disk to be able to improve or distribute that workload across. But yeah, how many files? Well, I go with the number of cores. Still stick to the old adage of if I have 4 cores, 4 files, 8 cores, 8 files. More than 8 cores, I stop at 8. Rarely, I probably less than I could count on one hand, did I ever need to go with more than 8 files, and that was back in SQL 2008 days. But yeah, so this is just how to properly configure. And you'll notice even when you install SQL Server, it's now creating multiple files based on that, or prompting you, creating the files based on the number of cores and with equal size. So each file needs to be the same size and auto grow at the same size, because SempDB uses the proportional fill methodology. So if you have one file that gets bloated, SQL will just want to continue using that larger file. Questions on this one? We just have a couple more slides. SQL Server agent alerts. This is just proactive monitoring. There are a series of errors that can occur within SQL that we call fatal errors. So those are your 19 through 25. There's some IO related, 823, 824, 825. If you look up Glenn Berry, SQL agent alerts, he has a whole even more alerts that he likes to use. These are the ones that you absolutely, beyond a shadow of a doubt, if you don't have third-party monitoring that's alerting on these, you want to enable these. It's free. It's free alerting. Enable database mail, a mail operator, create these alerts, notify when they happen. I did a blog post, I think it's out on SQLperformance.com, kind of going over these fatal alerts. And if I recall correctly, all but one means you're restoring from backup. So pretty important that you're notified as soon as these things start happening, so that you can address it really, really quick. Especially fatal error. Fatal means some operation didn't complete. User got a nasty error. They may not always call the help desk. They may not report that. I mean, all right, can't do it, and move on. But you getting these alerts means you can then start taking proactive measures and figuring out what's going on, see if you can repair or if you're having to restore.
Put it this way, if you see an 825, you run, don't walk back to the infrastructure team, and you say your storage is about to fail. You are going to have a very bad day.
Yeah, so to add on to that, IO retry means I tried to write to disk, I couldn't. I tried again, right? And I think it's is it 823, 824, or was it the 25? That was, I think it was the retry. It's just trying, and was successful.
825, that's the successful one. That tells me it tried more than once to write or read a block to disk. And if it eventually succeeds, your storage array is hours away from going belly up.
And this is the situation where you would notify the storage admins, hey, we're having a problem. Everything looks good to me, because they're not getting failures yet. Right. And it's like, no, here, I'm trying to write to you, and it took me more than one time. That should never occur. You need to do something. So that's the proof, right? That's showing up with the data.
The last time I saw this, we had a burst of them at 11 a.m. and at 1 p.m. the SAN failed.
It's kind of the sneeze before the flu, right?
I like that. I like that.
So if you don't have like a third-party tool that's including this monitoring, make it part of your standard deployment process. It's really simple. Again, another blog post here that will go, and all the scripts are there. You just create the mail operator, specify your mail operator, and just make it part of your standard build. It's all done through a query or through a script. This one, I came across this one a couple of months ago. Balance power. Hundreds. I think it was 400 and something servers in an environment, all running at balance power. It's like, hey, can you go change your GPO, make this high performance? And all of a sudden, you could visually see in their monitoring tool CPU utilization just across the board, just drop down, because the CPUs were being throttled. It wasn't busy enough. The cores start getting turned down. Eventually, they would turn back up. It's problematic. So yeah, there's no reason why, with the cost of SQL Server licensing, that you're dumbing down your CPUs to be throttled at a less gigahertz, megahertz. Um, SQL Server is not conducive to that type of behavior. Web servers, application servers, where it's typically load comes in and they go up. You can watch a SQL server, and it's like it gets scared by a mouse, right? It's like just flatlined, all of a sudden, jumps up and goes right back down. And then over time, you will see that some workloads, I mean, they build and you're sustaining 50%. Okay, well, maybe then had switched and it's at high performance. But you'll still see it's like spikes and go back down, spikes and go back down. It's just that the guidance is high performance. So your CPUs are always there at full capacity for you to utilize and not being throttled or reduced by the BIOS or by Windows. And so if you find it in balance power, reach out to your systems engineers, whoever's responsible for the operating system, and ask them to create a policy for any database servers. Hopefully you have a proper naming convention. And so if it's a database server, it's high performance.
You want a tidbit on this one?
Yep, go for it.
Believe it or not, setting this to high performance is 99% of the time the right thing to do. If this is a physical server, going to high performance will actually eliminate turbo boost on your CPUs. So every once in a while, I find a workload that is hot and sustained hot. Balance might actually allow it to turbo boost and get a gain. In almost all cases, though, high performance means highest possible base frequency, and you're better off. And that power setting for the network adapter, if anybody's out there, email me. I have screenshots of how to fix this, because this has been the source of too many availability group and failover cluster instance failures over the years.
It's like, what it just boggles my mind. Why turn off the NIC?
It's like, because we got to be green. Who cares? This is a production server during business hours.
Yeah, I call BS. It's like, as soon as they introduce AI, I'm like, do not talk to me about any emissions control, anything. With when you're having to fire up nuclear reactors to power a data center for ChatGPT. Like, I'm sorry. I've never met a data center where they have an EPA sticker on the side of the building. Like,
Exactly.
I'm sorry. All right. All right, this is one of my favorite settings. So SQL Server is great, but a next finish install. It's not so good. We have a lot of things that we can go and tune and touch and improve and make better. So first and foremost, backups. If you're a production DBA, you're responsible. If you're going to get the phone call, if that server crashes, in order to get SQL Server backup, you need to make sure you have proper backups, just period. Consistency checks. That's still you. That's recoverability. If corruption happens, when it happens, you need to be able to recover. You need to be regularly checking to see if it exists, so that you can then take appropriate measures while you still can without incurring data loss. And then just clean up. Just healthy stuff to do is this log cleanup with MSDB, backup files, those types of things, is just keep a clean house. Make sure your statistics are up to date so that Query Optimizer can have as much help as possible to generate a good enough plan, right? We can't say the best plan because it would take infinity to find the best one, but a good enough. And then that index maintenance. Like we said, there's some chatter back and forth on whether you still need to do it or not. I mean, that's for you to decide. I'm still doing it. Dave's still doing it. Take a look at it. Memory settings. Again, this is moved a little bit with, what is that proper setting? Again, it's going to kind of depend on your workload. What you want to make sure is that the OS has enough to do what it needs to do, SQL Server has enough to do what it needs to do, and the two of them are not bickering. Because as soon as they start bickering, where OS needs some, SQL has to give it up, OS uses it, frees it back up, SQL Server takes it, and they're just arguing all the time, that's impacting you. that when the parents fight, the kids suffer kind of thing. And the kids are your customers. So you want to make sure that you leave enough for the operating system to do everything it needs to do. And we're constantly competing with all of these other security tools and things. Max degree of parallelism. So when that workload is going to go parallel, how many threads are going to be used? You get to control that through the max stop. And then that cost threshold for parallelism. When is it expensive enough that it's going to go parallel? That you get to set, and that is mileage will vary. So some number, what I can say is 5 is way too low. So some number bigger than 5. What is the good number for your environment? 25, 50, 75, somewhere in there. I can say I've never set it to 25 and then had to adjust it down. I've only adjusted up. 50, I don't know that I've ever dropped it from that, but there's some folks say, oh, I'm going to do it 35. Just something more than 5, and then continue to monitor and tweak. TempDB, hopefully you're all 2016 and above, and you used let SQL Server allocate and create the multiple files and things. But even with that, the initial size is kind of small, 64 megabytes. You just want to make sure that TempDB has additional files, that it's of proper size, that it's not kind of having to auto grow out of control to get to its normal working size. So there are some TempDB best practices that you can follow. The free alerting SQL agent alerts, like I said, the 19 through 25, 823, 824, 825 for that IO retry. It's just good advice. It's a good best practice for you if you're responsible for the instance to be notified when bad things are starting to happen. It's kind of like having an alarm. You're being told that the system's sick. It's like that regular checkup. And then power savings. Like Mr. Clee said, 99% of the time, balanced power is bad news. If your big workload on-prem physical machine, maybe you want it to be on there if it's a sustained workload where you can get that that CPU boost. All right, so I mentioned, so Tim at Tim Brading, you can contact me, but these slides, and I didn't do any demos on this, but all of my sessions and stuff are out on my blog at timradney.com/presentations. So you can go find the common SQL Server mistakes and pull this down and have those links. And if you can't find it, just email me. I can send you the slide deck. And I know it's July 8th when I did this session, but if you're watching it in the future from now, still email me. I can send you the deck. And happy to answer questions.
So I'm looking through the questions here. We've got a couple on Azure SQL DB, but I think those were answered. Actually, we'll get your take on it. If you have an Azure SQL database, vCore model, and your boss asks you to provide IO telemetry, what do you do?
So you do, well, you really don't have a whole lot available in the Azure portal.
Yeah.
That's a great question. Let's see. So System IO virtual file stats would be at the instance level.
That's where I was going with it.
Is
Give
there
me
a
the
System DB file stats?
there's
I know
file
there's
those file stats that will give you enough. That's what I was thinking.
Yeah. So your file stats, I want to say yes, that you're still getting it. It's telling you at the database level. But what you'd want to do is capture that, and then after 5 minutes, 30 minutes, some interval, capture it again and do the deltas. So Paul Randall has a file stats over time where he's already got all that cooked in, where it's capturing into a temp table, wait for delay, capture it again, does the math. And I have a version of that you can look me up. I think it's on SQL Performance, could just be on my old SQL Skills blog, where I then also do the math to capture the throughput, because that's one of the big things when you're looking to, are you capping out on throughput in that vCore model? To know that you need to bump up. It's like, what is that condition? Because you do have throughput and IO limits in Azure SQL Database, Managed Instance, Azure Virtual Machines. So that's a really, really big thing to look at. But
Yeah.
I don't think there's a separate DB file stats. It's still the system IO virtual file stats. I know there's the
Yeah.
DB for weight stats where you're looking at individual database weights.
Yeah, that's what I was thinking. So Kevin, hopefully that answered your question. If it did not, shoot him an email, shoot me an email. We're happy to dig into this one further because there's a lot of good telemetry in the database engine. The Azure side is a little limited in what it provides, but we can get some good info out of there. Other than that, I think that was all the questions that are in here. If you have any other questions, feel free, show them, drop them in the chat window, or honestly, come off mute. But until then, if you are watching this after the fact on YouTube, do not hesitate, email us. And quite frankly, if you have a topic that you want to see, let us know. We're weird. We'll create sessions just for you because we love answering the stuff. These are core tenets of being a career DBA. You got to master this stuff, especially if you're walking into environments you've never seen before, like I do every day. These are things that you have to deal with. You just have to.
And I'm just now looking at the chat. Daniel Hopkins, you cracked me up. But yeah, no one knows everything. I promise you. It takes a committee. Just like David and I, we've known each other 15 plus years. I mean, there's areas I've dug deep into, um, and I'll get an email. Hey, have you ever come across this? And I do the same to David. It's like the reason that we give these sessions and these talks is we came across this weird stuff. So we want to make sure others have easier access to it than the blood, sweat, and tears we had to encounter to find it.
Exactly.
And this is all our community kind of coming together. I've done this talk hundreds of times, and people asking questions or raising their hand. It's like, hey, so I had this situation. What about something I didn't cover? Optimize for ad hoc workloads. David, do you turn that on by default?
Always religiously.
Always, always, always. Yes,
Yeah,
100%.
the only time it wouldn't help you is if you had a workload that shot over identical queries exactly twice, which
And
ain't
I
gonna
had
happen.
I had a guy in an in-person class. He's like, "Yep, we do that. Turn it on." Said this one particular workload, the developer had written it when they view a report. It runs the report, and then when you close the report, it refreshes. It's like, why? It called it again to refresh for whatever. It was just bad
Well,
code. They had to go in and fix that. But as soon as they turn on optimize for ad hoc workloads, their recompiles went way
weird.
up. Right. I had
Weird.
never in my life encountered where that would be bad. But just like you saying, well, balance power. Again, high performance, except if you have this one weird condition over here.
Yeah, there's
So,
always edge cases for
right.
everything.
But I'd never, I'm like, who would optimize for ad hoc workloads? It'd be
Yeah.
a problem. That guy.
There
It's like,
there's exceptions to every
yep,
rule everywhere.
yep,
There's so many situations where you just have to really dig in and try to figure out why. Why is this workload weird?
yep. All right.
So, Kevin, to answer your question, um, if you were just asked for IO, that does include both data and the transaction log. So the hard part there is to try to figure out why are they asking you IO values on that kind of setup. Um, I would provide both, or if they would actually get upset with you for providing both, if they just want IO, add them together because that's really all it's really doing under the hood.
Yep. Yeah, and it is good. I mean, if you're like the system IO virtual file stats, it's IO. So you're going to see the data file, the log file,
Mhm.
because I mean, if you know, your reads and writes should be somewhat, kind of isolated. There's going to be writes to your data file, of course, but there's going to be should be way overbalanced with read, but then should be over, for writes to the transaction log, and being able to look at that holistically for the whole database because in different cloud providers, like, and I know you were talking Azure SQL database, but if it was a virtual machine, you have different disk. So, well, this disk can have 500 meg IO throughput, this one 500, but the VM itself can only handle 768, right? So technically you have 1,000 gigabytes of throughput, but if you needed 700 for your read and 500 for your write to your transaction log, well, that data disk isn't going to be able to support it because it's going to be capped at 500. So there are reasons to be able to see them separated, but then sometimes you have to go and add those back together to see this particular database holistically needs X. So
Yeah.
for this database needs this, but the instance needs something else. But being able to get at that granular, we're data people. We can add.
I'm trying to dig up the query for him in here. So essentially, this is from the, there we go. This is from the Glenberry diagnostic scripts. I'm going to throw the query in the chat window here, and then I'm going to throw a link to this in the chat window. Oh, of course, it's too long. Here, just go.
GlenSQLperformance.com.
Yeah. This is the gold standard for diagnostic queries. They're amazing. Go here, look up a term called disk stall. This gives you the average and the sum. So you can strip it down and start getting the data, and then just like you said a minute ago, do a diff over whatever time period you want. Add the results together. There's your IO number. You can have it as granular as you want, or you can literally just add it all together to get a grand total, read and write, and you're good to go. Rock on. I think that's about it. So if you're watching this after the fact, once again, thank you. If you're watching this in person right now, awesome. If you have any questions with the stuff, let us know. Otherwise, thank you for attending, and we'll see you next month.
All right. Thank you all.